So we talked about some of those different things and we took a look at it. So once again, just a quick hit on the types of things that we do every day in our technologies. Let's talk about clustering and resiliency with Hyper-V. And this is where we get into some really exciting things that we can do, because everything we've talked about right now is just a standalone server and a standalone host. And if that host were to go away, how do we provide it back? So now we talk about clustering. And now this compares to HA. Normally this is probably the most debated kind of thing. This is just one of our components of how we provide high availability to our servers. But at the end of the day, it's clustering. So when I talk about clustering here, folks, and we go through and we kind of take a look at it and we demo it a bit, I want you to understand that how we look at clustering, this is, to Windows Server, clustering is clustering and clustering. It doesn't really care whether you're clustering Hyper-V or you're clustering a SQL server or clustering a web server or whatever else you might do with clustering. We're going to fundamentally treat it the same way and work with it the same way. Now, when you add Hyper-V on top of it, we then can say, hey, our cluster can go up to 64 nodes, and we can have up to 8,000 VMs inside those nodes, which, by the way, I always kind of personally don't like when I see 8,000 VMs, because when I think about that, and I think about those types of things that we have there, what if those 8,000 VMs were requesting 1 terabyte of RAM? Well, our limit is 4 terabytes of RAM on a server. Do we have 8,000? No. So whenever you look at those numbers, be realistic of what those virtual machines are actually using from a resource perspective. From there, I would imagine the 8,000 VMs that they had here were fairly minimal web server kind of things that they tested, but I don't know the exact extent we have. But how does clustering work? So clustering works from a standpoint of what we call a node and disk majority. We have a thing called the dynamic quorum, so we don't have to have that separate kind of server that would just monitor the cluster to make sure it's up. We actually let the cluster nodes determine whether the cluster stays running or not. So we have multiple nodes in these clusters. The design fails to fail it over, but there comes a certain point when you might have so many nodes fail that you want the cluster to turn off, and that's why there's a node majority vote of how we do this dynamic configuration. So imagine this. Let's say we have a cluster with 5 hosts in the cluster for us to work with it, and in 2 of those nodes, let's say nodes 4 and 5 go down, but nodes 1, 2, and 3 are still running. Well, they'll actually do a vote of who's going to be the primary the cluster host, but because they have the majority, 3 hosts are running versus 2, guess what? The cluster keeps running. But what happens if a third node goes down in that scenario? If you're doing the dynamic clustering configuration, you can configure this, by the way. It can still run with 2 nodes, but we no longer have a majority inside of here. So you have to understand how to plan this, but this is how we do dynamic quorum configuration. Now, regardless of what workload's running on top of it, this is what happens, and everybody kind of has that vote to see what happens inside of there to figure out how this works. Now, if you haven't played with clustering in Windows Server 2012, this is where we introduce this concept. And if you've done anything with Microsoft clustering, even if you date way back to the Wolfpack days, that's a 10-point bonus question for anybody who can tell me. By the way, the points don't get you anything, but if anybody can tell me what Wolfpack was actually released on, that's some good history for you right there. Something I can't get out of my brain. But if you understand clustering from how we used to do it, we took a really big change on how we did it in 2012. Even from the basics of configuring the clustering have gotten so much better. The wizards to validate the cluster to make sure that you have the right type of storage. So if you have a friend of yours that recommends you go buy a USB or an iSCSI device off of Amazon and it doesn't work, how do you know that it doesn't work? Well, a validation rule will tell you. All you have to do is get that friend to buy you some kind of payment to pay back for your shipping when you send the area back that we have. But we have the ability to do these types of things now with failover clustering. So we had that no majority in that vote to determine what's going to happen. So if a server does go wrong, how is it going to move those systems? Now, what's funny is how did the cluster move those workloads? Well, depending on what the workload is, it might vary. But in a virtualization space, if you're using live migration or you know it as vMotion, and Tommy will definitely talk about this, that's all it's going to use. It's just going to use live migration to move those running virtual machines from node 1 to node whatever it happens to be that it's going to be moving to. We've also reduced in 2012 AD dependencies. On this, you don't basically need to connect to DC to require for the cluster to actually start. This is important because if you set up clusters in prior versions of Windows Server, if AD wasn't available, your cluster wouldn't turn on, and what would happen there? is you wouldn't actually be able to have your environment turn on. And I've friends of mine, they actually virtualized their Active Directory domain controller on the cluster and rebooted the servers. Well, in prior versions of Windows Server, what would happen is the cluster would try to turn on, couldn't, because it couldn't get to the AD box. Why? Because the AD box was actually in the cluster. You see what happens? We've reduced those types of complexities, so things like that can be done a lot better. We have the ability to drain roles. We can actually go into maintenance mode, especially when we're doing cluster-aware updating, which we'll talk about in just a second. Failover cluster networking, we support the same kind of networkings that we have. We can actually use this for host management for Hyper-V hosts through RDP, Hyper-V Manager. We have dedicated NICs for the VMs. We support live migration. We actually use cluster shared volumes, are basically how we store our data for our cluster and our information for our cluster that's out there. And what happens if the access gets interrupted, the cluster shared networking will actually use that storage and assign from it, and we actually can have a separate storage network. So when you set up a clustered network, and if you ever get a chance to come see Tommy or I or Brian or Janelle or Young present this live, the demo environment that we use actually has several of these networks defined, and all we're basically doing is controlling what type of traffic goes over certain things for the health of the cluster. So we don't, so our storage traffic doesn't have, cluster communications happening across it, but our heartbeat traffic and things like that do support that. Just like VMware, we support failover priority, preferential treatment of our nodes. We have support affinity and anti-affinity rules here, and what this basically means is that when you have a cluster with multiple nodes, and let's say you have, we'll just make this one simple, we have a 2-node cluster. What I can say is, okay, this virtual guest, I want it to run on 2. 2 is what is known as preferred owner, and I want it to run on 2 if it's available. But if 2 is not available, it can run on 1. That's basically a priority or a preferred owner. And what I can do is say, if I have 4 nodes, and I have nodes 1, 2, 3, and 4, and it's running on preferred owners 2, well, if node 2 fails, I can say, which one do I want it to fail to? Who is that preferred failover point for that particular guest, so I can run the workloads? Because it might be a VM that needs more memory or needs more resources or go to those types of things. Now, we actually do dynamic resource allocation as well through VMM, so we can actually have the cluster kind of make that decision for us, saying, hey, based on what this virtual machine is doing, I'm going to put it on a node based on the intelligence that I see, just like we have before. We can also do affinity and anti-affinity rules that allow us to control where those actual nodes run. So if we have a restart priority order, if we have to restart a node, we can say who starts first. So we might have we might want the back-end server to come up before the front-end server comes up if we have a 2-tiered application, for example. We have the ability to have anti-affinity saying, hey, you know what, based on these 2 servers, they can't be together, because if both these nodes go down, it kills the entire application that we have on running on top of it. It allows us to keep those VMs apart. And affinity rules allow them to run together if they want this. We can actually do cluster-aware updating. This compares to Update Manager, but we actually use WSUS under the covers, and you can actually do this either just with the built-in clustering tools, or you can use VMM to actually help provision and create baselines for your Hyper-V hosts and do a little bit more robust nature for those actual Hyper-V hosts that you have in your network. But it allows us to actually go in and update a cluster with essentially one click. Now, you might be thinking, wait, that's crazy. No, it literally is update this cluster, and what it's going to do is roll through that cluster automatically, moving workloads from one node to the next, and as it moves those workloads off, it puts those nodes into maintenance mode, updates them, brings them back online, and then possibly moves workloads back to it, and then it keeps going down the cluster to work with it. What's nice about this is you can be selective of which updates you apply or don't apply, just kind of core WSUS functionality that really allows us to work with and modify those clusters and keep them up to date. Because we all know, regardless of what environment you run in, you're going to have updates to update those hosts and update that environment. Maybe there's security patches, maybe there are bugs, whatever. You're able to do these things fairly nicely with just a cluster-aware update we have, and the ability to do that inside of our technology is actually quite easy. Whether you're using just Cluster Manager, whether you're using VMM, you can do these types of things very easily as it moves those workloads, settings, and patches, and it just eventually moves down the line for us to work with it. Okay. So when we look at the comparison here, from an HA and clustering perspective, the only difference here is that we support 32 more nodes and up to 4,000 more guests per this. Whenever I think about this, and Tommy did the scalability slide in the very first section today, how many I would just like to have a system where I could have 64 nodes. I'd like to have that much hardware. It's Christmas time. Or it's the holiday times out there, so if anybody wants to send me 64 node clusters so I can test it, I will tell you how many virtual machines I can get running on it if I can get 8,000. Being the overachiever that I have, I'm going to try to get at least 8,001 just to say I can outperform what we have. But understand, though, these are things that we have built into Hyper-V, where to get to some of this level, and this is just basic things that I can do with the Hyper-V tools, you'll need Enterprise Plus to do these same type of levels of clustering. Remember, this is just where we see that big difference between what I can do with Windows Server built out of the box and the type of tools that we have. So you have some really, really nice abilities built into this. Speaking of clustering, we can actually do guest clustering as well. And this is the beginning of a joke that I have yet to finish. We're running a cluster on top of a cluster, and that's essentially what this allows us to do. What's funny is if you do any of the TechNet virtual labs that are in your links and in your screens that I know or that are provided for you up on the TechNet virtual lab environment, this is essentially what you're doing. With some of those environments, you're actually doing a cluster on top of a cluster from a Hyper-V and virtualization perspective. The challenge with this, when you think about this from a virtualized environment, is that when you have a guest cluster running on top of a Hyper-V host cluster, we still need the same kind of things that our hosts need. We still need access to shared storage for our CSV. We still need to be able to support dynamic memory inside of there. We still need to do affinity and anti-affinity rules. The great thing about this is that when you cluster, and if it's a Windows OS, it works almost identical and is configured almost identically to how you would configure your actual hosts that we have inside of here. So from our standpoint, you see a lot of these nice things inside of that guest cluster to work with those types of things like virtual fiber channel, maybe iSCSI or SMB storage down to that actual layer. So that cluster thinks it's a real cluster running on a real piece of hardware. And if something does happen, guest cluster nodes will restart on another. If a physical host goes down, that clustering has to be able to restart on the other that node. So it kind of gets a nice way to do these types of things, but provides that nice level, app level, high availability that we need, especially in some of those larger infrastructures. Just understand that we can do those types of things. And then eventually it'll move back based on the rule. One of the things we actually introduced into R2, and hopefully you like kind of the concept of using storage pools and local storage where I don't always have the ability to have a SAN type of environment or a high-end device or something else that's providing storage. One of the things that we actually introduced in R2 is a concept called shared VHDX, which allows us to simply take a VHDX file and provide it as storage to multiple VMs. It's the same VHDX file there. Now, why would we do this? Well, we're talking about clustering, so that must be one of the reasons we're going to do this here. Well, think about this. If we have a thing called a clustered shared volume, that means that all nodes in a cluster have to be able to talk to the same type of storage. What makes this great, what makes shared VHDX great is that we can actually make this VHDX file the CSV for our clustered node environments. You can also make it an SMB share for file-based storage. So maybe it's some things that you're doing for both those VMs to be able to work with and use and leverage those environments inside of there. So we have the ability to work with this. It can be a dynamic or a fixed size VHDX. Depending on your cluster and your nodes, you might want to make that fixed. Based on what you're doing, though, there might be needs for dynamic. Just my own kind of personal Matt Hester recommendation for that. But we have the ability to do those types of things now. So we have that shared file that essentially becomes CSV file, or we have that shared file that essentially becomes just an SMB share, or maybe it's a file that has scripts or things that we need to use to help provision that server or whatever it happens to be. We have very easy ways to manage that. So when you look at those different guest clustering nodes that we have a lot of improvements here of how we support all the guest clustering. And really, this is the difference. One of the big differences of how we approach guest clustering and how we deal with it is one of the big differentiators between of how VMware approaches it. But the fact that we can support live migration inside that guest cluster and dynamic memory support provides a lot of abilities to do those types of things. And you see a nice little comparison chart there for you. So let me go ahead, and I'll turn it over to Tommy here in just a second, but let me just give you a quick tour. So I'm going to go ahead and bring back up my little demo environment that we have. So hopefully it should connect here in a second. I'll let Eric or Tommy just let me know when everybody's seen it.
And it's still coming out, just to let you know. We're just watching for it to come up here. It takes a moment. Sorry about the delay on that, folks. It looks like it'll be up here in just a second.
Okay.
That.
Give it a second here.
You can go ahead and should come up any moment now. Sorry.
Okay.
And we can see it now. Go right ahead.
All right. Thank you very much, Eric. So there's a couple ways to look at your cluster. So the first thing I want to do is I'm actually going to hop into Cluster Manager before I go down the VMM path, just to kind of give you an idea of some of the enhancements we built into the tool. Now, some of this may error out because I've already created a cluster. And to kind of give you an idea of this environment that I'm in right here, I have the System Center Virtual Machine Manager box, which is I'm logged on here. It basically has VMM installed. It's also my central point of management server. I have a DC floating around. I have a file server floating around. And then I have two Hyper-V hosts. So for this demo that you're actually seeing, I'm actually using just Hyper-V server. I'm not using any other environment that we have. I'm actually only using the free Hyper-V server. Those aren't Windows servers at all. They're just Hyper-V servers that are floating around. So when we look at the networking that's here, this is just my cluster things that we have. So I can see any storage that I may have assigned to this. Any pools, I have my cluster shared volume is currently running. The owner node is my virtual machine 2. If I had any pools, I don't think I do on this particular one, nope. But I have the ability to work with this. So inside the clusters, I have roles. Now, roles are kind of interesting because roles could be things like the Hyper-V replica broker, or they could be virtual machine resources that we have. So if I right-click on this and just say configure a role, it's going to ask me what roles that we have. Remember I talked about cluster to Windows environment does more than just Hyper-V. These are the types of things that we can do inside of here. It's just some of the basic for generic applications. We can do scaled out servers. We can do Win server. That one always cracks me up. And anybody has a Win server floating around, you can do that. You can do iSCSI target servers if you're clustering your storage for that kind of environment. We have iSCSI targeting software built into Windows Server now. It was a download for 2008 R2. We have the ability to do these types of things just out of a base cluster. So clusters can do a lot more in a Microsoft environment for us to see. If I cancel that, the one that I'm not going to mention because I think Tommy's going to talk about is the Hyper-V replica broker role. Well, we support things called replica, but what if you want to replicate to a cluster? What if you want to take a virtual machine and replicate it to a cluster node? You have to use the Hyper-V replica broker role that you configure on your actual cluster for that to work. So if I look at my cluster, one thing I just want to bring up, and I'm hoping it'll show me the rule. I'm going to click on Validate Cluster, and I just want to show you what goes on behind under the covers. So I'm going to say Run Only the test. I'm not going to run this because it takes about anywhere between 10 to 20 minutes to actually run. But when you look at, if you've done clustering in Windows software before, you might have wondered what was it actually checking or looking for. So if I see all the configurations that are here, I can actually see all the different tests that it's looking for. And if I click on the test, it'll give me an idea of what it's looking for and what it has to pass to be an officially supported. If your cluster validates. If it validates, it'll be a fully supported cluster to Microsoft. In other words, if this wizard works and it validates your cluster, you're going to have a supported environment. So whenever you build your cluster for the first time, one of the first things you'll want to go through is validation to make sure that you have shared storage, make sure security is all set up. Any of the roles that we want to be able to do, it's going to validate that all across that for us. I'm not actually going to run this. We've gotten a lot better at how to actually provision and work with your clusters inside of your environments. And I don't know if I have it here. Let me see if I can actually show you one. I don't think I have a validation report created yet. I actually created my, I do. So I actually have my validation report. This is what it'll spit out when it's done validating your cluster. And if I look at it real quick, I can get networking. I have a warning there, IP configuration, and I can scroll down and get an idea of what actually is happening for that particular configuration. It might be just a missed IP address. Here it is. Hyper-V has an IP4 configured as automatic private address. So it's basically telling me, hey, my networking want to warn you, it may not be the way you want it to go. So you find those types of things that I have inside of here. Now, one of the things that makes VMM kind of a special product standpoint is that I can actually come in here and actually add in and create clusters inside of my virtual machine environment. Now, I'm going to talk more about what VM can do, but I can actually process and create and manage this cluster all from within inside of here. So I can migrate the storage, I can put them in the library for other things to use. I have the ability to do this type of stuff all from within inside of VMM. So you don't need to float back between Hyper-V Manager and Cluster Manager. But what I think makes our solution very interesting, it lets you pick. Maybe you're not in a place where you want to get a hold of System Center yet, and VMM is not an option for you and your environment or for you and your company as of yet. You still have some very powerful alternatives to manage your virtualized environment. VMM is going to add a layer, as we'll talk about later, that makes it very, very easy to work with it. One of the nice things, though, in the library that I have is I actually have update baselines. And what this allows me to do is when you think about updating your cluster and updating this environment, how do you control, how do you get those updates and those environments working for us? So what I can actually do is I can actually say, and let me look at the properties, I think it'll show me. If I go to updates, it tells me which updates this baseline applies to. So in other words, I want to make sure, and I can take this baseline and apply it to my cluster, or apply it to my Hyper-V hosts for that matter, and say, hey, look, they have to meet this update standard. They have to meet this. Now, granted, this is after you test it and make sure things are working, but what it allows us to do is to make sure that our hosts are at a consistent level. So we don't run into that issue, oh, yeah, I forgot to run that patch on that system that I have. I have the ability to control those types of baselines and then apply those baselines to that actual update. Notice just like WC catalog that shows me all the different updates that I have inside of my environment. All right, so VMM looks at this from a very different level. Let me show you the alternative, and I should be able to bring this up if everything's working in my demo environment. I actually have the ability to create a cluster-aware updating, which is just built into our clustered environment. And if I look at these different clusters, I haven't run it yet on this particular one because I use VMM to manage this particular environment. But what I can do is say, let's preview updates for this cluster. And I think I can actually click here. It's going to show me if I have any updates, and let me see if I actually can generate some for it. It may not, based on I've already updated this cluster, but the point is I get the ability, I don't have any updates, of course not. I don't have any updates here, but what's nice about it, even if I had it, I can say, okay, these are the updates I want or the updates I don't want. And with one click, I can simply say, after I've chosen my updates, simply say apply updates to this cluster, just like my baseline would do that for me in VMM. This is the free tool that'll say update the cluster. And what it'll do, beautifully done, is it'll put one cluster into move all the workloads off and put it into maintenance mode, update it, move stuff back, and then put the other one in maintenance mode and create it. So we have the ability to do these types of things. You could even do self-updating options as well, so these servers can get up to space. Although generally speaking with clusters, most customers want to be aware of which ones they update and how they update them. So we have the ability here to be very smart with how we update, how we manage our clustered environments. Bear in mind, we just happen to have Hyper-V running on top of this as one of the roles, and we can control those virtual machines that are there for us to work with it. So there's lots of different tools that we have here. You know what? One last thing to say, I want to show you, and it's kind of a little extra tidbit here, and I forgot to show it to you earlier. If you're not new to Microsoft virtualization technologies, one of the things that might be a point of frustration for you was how we connected into our virtual machines. So when you brought up the console, you couldn't do things like, it wasn't like it was kind of like a remote desktop session, but it really wasn't a remote desktop session. You couldn't share a clipboard, you couldn't share local resources and things like that. Well, one of the things that we actually have in our settings now for the Hyper-V host itself, we actually have the ability to do inside of 2012 R2. This is just an R2 feature only. This is a little bit of nugget before I turn it over to Tommy here in just a second, is we have enhanced session mode. And this makes it more like an RDP session where you can copy and paste from the local host resources into the actual guest. So if you had prior versions, or if you used prior versions of Microsoft Hyper-V, first off, thank you. Secondly, well, how did you get like a local script that you use to provision your Active Directory into that guest? You had to go through some kind of funky way to set up some kind of network share in the guest that you could talk to the host, and you copy it that way. Or you did what I did. I would email myself my file, and inside my inside my guest, I would log into my email and do it that way. Yes, it's cheap, but it works, folks. It works. But enhanced session modes allows me to essentially just copy and paste, connect to a lot of other local resources, but you get the point. And I forgot to show that to you earlier. I don't know if Tommy did earlier, but it's just one of those things that kind of spun in my brain of how we connect and work with our virtual machines. So I'm going to go ahead and go back, and I'm going to stop presenting and let Eric bring back the deck up, and I'm going to turn it over to Tommy, because we're at the stage now where he's going to talk about some other great things that we have inside of our virtual machine environments for us to work with it.